Hi, this is my Unit 4 mini assignment response, and seeing as I only have 5 minutes on this free program, I'll try to make it quick. So I started off by making a checklist for what I need to do. So number one was the function must be a rational function in this form. A rational function is a function where its numerator and the denominator are both polynomials. So as you can see, they are in fact both polynomials. So I would say that number one is ticked off. Number two is there must be a y-intercept. So if we look at our graph, we can see that there is in fact a y-intercept at 0.482. So that's number two ticked off. Number three is domain has exactly one restriction. So in order to do that, I would say when we look at this graph that we would have to look at the vertical asymptotes of the graph. So when we calculate the vertical asymptotes, we can see that the two vertical asymptotes we get are x equals -4 and x equals -14. If we were to plot both of them on our graph, we can see that we have our two vertical asymptotes in place. And another criteria is that we must have exactly one vertical asymptote, and on top of that, we have the exactly one restriction. So when we do that, our best case that we can have is we get rid of this vertical asymptote and we add the restriction of x has to be greater than -4. Uh, so in doing that, we have a vertical asymptote and we also have exactly one restriction, and they just both happen to be the same number, so that's a win. That's two boxes ticked off. And then we have the range has at most one restriction. As you can see on this graph, the very lowest point that we have, our absolute minimum, if you will, on our graph is -3, 0. So that means that our range is y is an element of the real, whereby y must be greater than 0. Sorry, greater than or equal to 0. And that's our range with our one restriction. And you must have at least one horizontal asymptote. So if we look at the graph without our restriction here, you can see that this graph does have a horizontal asymptote. It's just that it's a crossover horizontal asymptote. And the way we find our horizontal asymptote is by looking at the degree of the numerator and the denominator. In our case, the degree is 2. And we look at the ratio between the two. And in our case, since the coefficient over here is 3 and the coefficient over here is 1, we look at the ratio between the two. So we have a horizontal asymptote at y equals 3. Oops. That's exactly what we have here. That's our horizontal asymptote. And if we were to apply our restriction back, here we go. That's our function right here. And then let's go back to our checklist over here. So must have one horizontal asymptote, that's ticked off. And then there must be exactly one turning point. And as you can tell, once the restriction is applied, we have exactly one turning point. There will be no other because this end tends towards this asymptote. So there can only be one um, local minimum, and that local minimum also just happens to be our absolute minimum. And then we have the critical number for your turning point must be negative. So in order to find the critical number, you have to take the derivative of f of x, and you have to look at the x-intercept of the derivative of f of x. So our x-intercept here is -3, 0, and that just so happens to also be our local minimum. So that's kind of nice. And that right there is your critical point. So our critical point is -3, 0, and our critical number is just the x value for that, and you can tell that that is in fact a negative over here. So that's a -3, so our critical number does in fact match our criteria. So I believe that's everything. So yeah, thank you.